Hello friends, today we will discuss chef and surprise chessboard problem. In this problem, you are given a n cross m matrix, which is a chessboard, which each value of the cell of the matrix is 0 or 1. 0 represents white and 1 represents black. Let's say a correct chessboard is a chessboard whose width is equals to height, and the cell of each correct chessboard has to be should not have a side adjacent cell having same value. In other words, you can say it's a square matrix in which each cell doesn't have a side adjacent cell having equal values. Okay, you are given an operation where you can convert 1 to 0, 0 to 1. Okay, there are q queries. In each query you are given a number. Let's say that is Ci. It means you can do at most that number of inversions. So you have, for each query you have to answer what is the maximum length of the correct chessboard in which you can do at most Ci number of inversions. Okay, or in other words, maximum length squares some matrix which satisfy these two properties in this n cross m matrix, in which you can do only Ci number of inversions for that query. Okay, these are the constraints. M is less than 200, number of queries is 10 to the power 5, Ci is less than 10 to the power 9. Let's see first how we can form a correct chessboard. There are two ways. First is start with 0 and then alternative 1 0 to satisfy this property, and second with start with 1, okay, and then 0 1 0 satisfying this property 2. These are two examples of 4 cross 4 correct chessboards. This starting with 0 and this starting with 1. Let's see what's the maximum length of correct chessboard I can form out of n cross m matrix. This should be minimum of n comma 1. Why? Because of the first constraint, that width should be equal to height, and whichever is minimum, I can have that many length and that many column in a square sum matrix. Okay, let's see the brute force solution. But for brute force solution, I have to iterate over each length. I'll iterate over each possible length. Let's say from 1 till len is minimum of n comma m. Then from every point I will try whether I can form a matrix with that length, and if I can form, what is the value of value of number of inversion required to form a correct chessboard. Okay, that we can do by just this will be the topmost left corner, this will be the bottommost right corners. Now I can just iterate over the matrix and can find the number of inversions required. Okay, so inversions required, and I can update my answer that for this k this many inversions are required. And finally, after processing each part, what I can do is, for each k, what is the minimum? Here I can have what is the minimum Ci, minimum inversions for given k. Okay, and I'll check for this query, for a given query, if this is less than if this is less than the value in this query, I'll update my answer. Let's see what's the time complexity of the solution. For this, it will be a length, and this n minus k, m minus k, and iterating over this, it will be length square, whatever length is, that is k square. So what I can say is, this will be n minus I plus 1 plus m minus I plus 1 into I square summation. If I do summation, I can say this is the complexity of this solution. Why? For this n minus I plus 1 into m minus I plus 1 says at how many submatrix are there. For each submatrix, I am doing I square iteration to find the number of inversions, this part. Okay, So this will be approximately of order of n to the power 5 when n is equals to m and equals to 200. So it will be around 200 to the power 5, which will definitely time limit exceeded, because for each query we are repeating the same thing. What we can do better is, we can easily see that since the matrix doesn't change, we don't need to calculate everything again and again. What we can do is, we can maintain a map for each k, what is the minimum number of inversions required. Then finally we can convert that map into an array which has which is a tuple, having first as an inversion and a number of inversions, and second is the length. For given length, what is the minimum number of inversions required. Okay, and then I will sort that array, and for each query I can just binary search over this array that what is the binary search for a given query, what is the maximum length I can form, because since number of inversions is sorted, I have to just find the index of just less than equals to the ci value which is given in the query. Okay, so per query, what will be the time complexity? Order of log of min of n comma m. Why? Because this array will be of length of min comma n comma m, min of n comma m. Okay, and doing a binary search is a logarithmic complexity. Now how can we improve this part? Because per query we have improved, but still this part is O of big O of n to the power 5. Okay, let's see what we were doing. We were finding for 1 cross 1 matrix, then 2 cross 2 matrix for given ij, 1 cross 1 matrix, this part, then 2 cross 2 matrix, complete for 2 cross 2 matrix. First we find it 1 cross 1, then 2 cross 2, and then 3 cross 3. What we can see is, in 2 cross 2 matrix, number of inversions will be always greater than equal to number of inversions required in 1 cross 1 matrix. Why? Because that 2 cross 2 matrix contain that 1 cross 1 matrix. So if I know the answer for 1 cross 1 matrix, I just need to calculate this green part, number of inversion required for this green part. Okay, similarly, if I know the answer of 2 cross 2 matrix, I just need to find this blue part. Okay, that is the last row and last column. Similarly, I can say, if I know if I have to find that from I comma j, j as the topmost left point of a square matrix, I want to form a k length correct chessboard, then this will be just this summation of I comma j, from I comma j topmost point, topmost left point of some matrix of length k minus 1, number of inversions required for this k minus 1 length, plus the last column number of inversion required for the last column, that is this part I can say for this thing, and last row of the this k into k matrix, and finally minus this common cell. This common cell you have to minus it. This I can use. Now let's see what would be our time complexity. Just to give you a pseudo code of this algo, k is 1 for every I comma j. I'll calculate it for every how. There's a single cell, it has to be 0 or it has to be 1. If it's at the start only I told you there can be two type of matrix, one with starting with 0, other with starting with 1. So for length 1 I can just check if it is 0. I'm giving an example of if all the matrix starting with 0. So then if the matrix value is 0, I won't increment by number of inversions required, else I will increment the number of inversions required for one length matrix for every I comma j. Every I comma j means for every point in the matrix. Now for k is 2 to length, I'll use the above recurrence for every ijk, and see this part now has been reduced from i's length square, whatever the length was earlier it was k square, now it has been reduced to k. Okay, so what will be the time complexity now? this will be the summation of n minus I plus 1 into m minus I plus 1, that is the number of some matrix of I length multiplied by I for this loop part, which will be of order of ON4, okay, and which will which got accepted because it's around 200 to the power 4 and it's got easily accepted. But we can further reduce to ON cube. How? What we are doing is, at every step I have to calculate for the last column and last row. What we can do is we can pre-process this matrix in some other array, let's say array B, and we can maintain a array which gives me an information. If I start from this point, this jth ith I comma j point, let's say I say this is the I comma j point, what will be the, and this is my end, this I say, let's say k comma m comma n, let's say, what will be the sorry, the column should be same, m comma j, what will be the minimum inversions if I follow 0 1 0, if it is 0 then if this element has to be 0, then what is the minimum number of inversion required for this column. Similarly, I can maintain an array to find number of inversion required for this row, okay. I have to maintain this information for every row and every column, okay. This can be easily done using cumulative sums, okay. So by that way I have moved this part out to O1, okay. So overall complexity then in that way can be reduced to ON cube. But for the problem where the O of n to the power 4 was acceptable solution. Thank you.